Okay, so real quick, sorry, let me fix this. I'll put me right here. All right, so we're going to talk about glaciers. Today is the last day of new material for Unit 3, weathering and erosion. I know it was really fast. That's just how this unit is. It's not a very long unit. So what's happening next week? I told you before, benchmark on Tuesday. No school Monday. Benchmark on Tuesday. Wednesday, we're going to have review of the whole unit. And then on Thursday, you're going to have your test. I do apologize for those of you who have the benchmark in another class. I really wish it didn't line up this way, but it did. So you'll have the test. The benchmark is only going to be 20 questions long. The test is going to be the normal 50 with bonus. I will also let you know we're going to start the new unit on Friday. Friday is also the last day of the 5-week period, which means that's you've got until Friday to get me everything in. That's labs, quizzes, tests, notes, everything. Again, with the quizzes or the tests, which I'm not too pleased about that some of you haven't gotten it done, but you got to get a hold of me and say, hey, Miss Co, I need help. I missed it for this and this and this reason, so that we can get you caught up and get you the grades so that you can be passing. You also need to know this material, so it's not something that you can just blow off. Make sure you get the material, all right? Okay, so glaciers. Really, really cool. Right there. Glaciers can pick up boulders, cobbles, pebbles, sand, silt, and clay. So it can pick up everything. They're a powerhouse. They are flowing. Yes, they're solid. They're solid ice, but they're flowing. They actually move, which I find kind of cool. All right, so where the heck did they come from? What? So the Earth has been through 5 major ice age in its history. One that lasted over 100 million years. Yeah, I think that's when it was called Snowball Earth. Like it was like all of Earth was covered by ice. We'll get to that. You'll see that in a couple units. But there have been, besides the 5 major, there have been a lot of minor glacial periods, which happen about every 100,000 years. And the last one that ended was approximately 11,500 years ago. So we've got some time. Although with global warming, it may speed up. All right, come on. All right, so there are 2 types of glaciers. Let me move my face. There are 2 types. First is considered continental, which means it covers entire continents like Greenland and Antarctica. Those are totally covered by glaciers. And then the second type you have is mountaintop, which are the smaller glaciers. So right here you see continental, and right here you see mountaintop. And that's a lot smaller than that one. Glaciers either advance or retreat. Are either advancing or retreating. I'm sorry, it should say retreat. At the present, glaciers are currently retreating or melting due to global warming. Now, that's why I've got this picture right here. So, 1913, this picture was taken of Athabasca Glacier right here. You can see how far it is. Now, in 2011, which was well over 10 years, almost 10, sorry, not well over, but almost 10 years ago. Look at it. Look at how much it's like retreated. And global warming, how does global warming, what is that from? Remember burning coal, lots of carbon dioxide being put into the atmosphere that causes some global warming. All right, glaciers form up in mountains where it continuously snows, because the higher you get, the more snow, the colder it is. So all this snow is falling, and it doesn't have a chance to melt. And it builds and builds and builds and builds and builds on each other. And with all of that building, it starts to pressurize, and it packs more and more and more and more, and that forms ice. Now, in the winter, I don't know if you dealt with this. I deal with this. When it snows and then it kind of like thaws out a little bit, and then it snows again, like it refreezes, and it like packs, like on my deck, it'll pack and it'll pack and it'll pack. It actually forms layers of ice, which really suck to shovel off. So if you've had to deal with that in the winter, that's like a mini little bit of what could happen up in the mountains and in the glaciers. It just packs and packs and packs and packs and forms ice. As I stated earlier, glaciers are retreating at this point in time. When glaciers slowly advance, they collect various particles along the way, rocks and all this other stuff. And you'll see in the ad puzzle after this a little bit more detail. So glaciers slowly advance until they stop, and then they start to retreat. At this point where they stop, it is called a moraine. And it's usually denoted by something that looks like this. This is a ridge, and that's unsorted sediments and particles. So you see this big boulder right here, but then you see big ones right there. It's like it just dumps it. All that stuff that had been pushing and moving with it, it just dumps it and then retreats. So when glaciers melt and deposit material, it is unsorted. It's capitalized for a reason. It is unsorted, and it is called glacial till. All right, so some pretty cool things that happen after a retreat. Glaciers are very heavy. They're very, very, it's a lot of ice and very, very, very heavy. And when it starts to retreat, sometimes like chunks of it break apart from the actual glacier. And it sits over this land, and because it's so heavy, it starts to push down the land it's sitting on. It depresses it inwards, and it leaves a large depression in the ground. I should say depression. When the glacier finally melts, so you have this big old chunk of ice, when it finally melts, it forms a kettle lake. And then you have something else that's formed. So glaciers also leave deposits of sediments. Remember, they're unsorted, that form long, thin hills called drumlins. I don't know if you guys have heard of Drumlin Hills, which is a golf course. Drumlins, I don't think they're as bad, but they have one gentle slide. There's the gentle slide right here, and one steep side right here. And you can see gentle, kind of steeper than this side. And they're typically about 100 feet tall. So they're really, really long, thin, tall drumlins. And they point in the direction of the ice flow, which way it was going. All right. And then you have these right here. These are called striations, or scratches in the bedrock, that are formed when glaciers carry boulders near the bottom of the glacier. So those boulders, they fall off and they get into the glacier, and because they're heavy, they kind of sink to the bottom. And as they sink to the bottom, because it's flowing and it's pushing, it's going to push that big old chunk of boulder right along the bottom, and it forms these lines, these scratches. So as they move along and drag along the bedrock, it scrapes it, it scratches it. Okay, and then you have these really, really cool things. I love these. I love this term. Really huge boulders left in the middle of fields, like left in the middle of nowhere by glaciers, are called erratic. So think of it like erratically placed, just like randomly placed. Look at this. This is so cool. It's like placed right there and precariously sitting on that. Same with these, precariously sitting. That's just like, man, it's plopped right in the middle of nowhere. All right, and then you have these long winding ridges that that are composed of stratified sand, gravel deposited by subglacial or end-glacial meltwater stream. So it happens on the bottom part when it starts to break up and move away. And these are called eskers. Okay. They kind of look like natural fences or barriers. Look at that. It looks like somebody put a fence up, but it's actual land. It's natural. Okay. So the last bit of this. How can you tell when a glacier has passed through a region? How do you know a glacier has gone by here? Well, we already talked about rivers in topography. Rivers actually have a V-shaped valley. So remember the laws of V? Well, this goes along with it. Rivers have a V in it. The laws of V, the arrow points to the origin. They actually have V-shaped valleys. And this is, I wanted to get a good picture so you can see the V-shaped valley. Now, glaciers, they form U-shaped because remember, it could start out like this, but because it's like the glaciers weigh so much, it pushes and pushes and pushes, and it kind of curves it out because nature likes circles. Remember, all that pressure, it depresses the ground under the glaciers, and it forms these curves. All right, so we are done with notes. This is the last notes. This is it. I'm going to play, there's a little video that I highly suggest you watch, a little bit more information on glaciers. And then you're going to use your notes from today and yesterday and even the day before to take the quiz. It is 10 questions. The 11th is a bonus. It is going to be open all day. If you had issues with yesterday's work, please let me know. I do apologize. There was a glitch in Google. I have no clue what happened. It was scheduled to pop in there at 8 o'clock, and I didn't notice it till later in the afternoon. So if you didn't get it done, don't worry. I'm not going to take late points off for it. Pardon me, but it does need to get done. If you have any questions, please let me know. Make sure to hop on Zoom, class tag, email me, and I'll get back as soon as I can. All right. Have a great day.